Hello, wonderful grade 11s. Welcome to the lesson. We are going to be marking and working through exercise 3 from your trigonometry chapter in the textbook. Let's get stuck right in. This first one should just be looking so nice and easy. If 5 sine theta plus 4 equals 0, okay, so there's my first piece of information. And cos of theta is greater than 0. There's my second bit. Find the value of tan theta times cos theta. Okay, cool. So we want to take the information which I've circled in red. The 5 sine theta plus 4 equals 0. We want to create that fraction, that ratio. So I want sine to be alone on the left-hand side. So I start manipulating this equation. So I subtract both sides by 4. And then I'm going to divide through by 5. So I get that sine of theta is equal to negative 4 over 5. So we can see here, now that I've simplified the ratio, that sine is negative. So let's get a little Cartesian plane going. Remember, we need to make a sketch. So the question didn't tell us to make a sketch, but we know we need to now make a sketch. So this is CAST. Okay, cool. Let's mark off, okay, the quadrants where sine is negative, quadrant 3 and quadrant 4, tan and cos's quadrant. The second piece of information says, where is cos theta greater than 0? So in which quadrants is cos positive, right? That's what that statement is saying. So we know that happens over there and over there in quadrant 1 and 4. And we see, where does information overlap? Hooray, in quadrant 4. So I know then this is where I'm going to draw my cutie patootie right angle triangle. Okay, so there we go, something like that. 90, the angle they gave me was theta. So sine is opposite over hypotenuse. You find your third side using Pythagoras. So 3, 4, 5 is a Pythag triple. I promise you that length there is 3. It will be positive 3 since we're on the positive x-axis. All right, so this is your sketch, and we're going to use this now, boom, to answer this. So the question says, find the value of tan theta times cos theta. What is tan theta times cos theta? Well, tan in this triangle, opposite over adjacent. So that's negative 4 over 3 times by cos of theta, adjacent over hypotenuse. So that's going to be positive 3 over 5. Hey presto, negative 4/5 would be my answer. Right, remember these 3's will just cross cancel. And you've done question 1. Wasn't that easy? Let's have a look at the next one. Right, let's check this guy out. If tan theta is 12 over 5, oh my goodness, they've simplified that ratio already. You don't have to do anything. All right, that fraction is positive. So you're marking off the quadrants where tan is positive. Boom, boom. Quadrant 1 and 3. All right, what's the second piece of information saying? It's saying, look, if the angle lies between 90 and 270, so 90 and 270, all right, that's quadrant 2, and then quadrant 3. Where does information overlap? Quadrant 3. So that's where we're at. You got to draw that little baby right angle triangle. Nice and easy. And then we have to fill in the two sides that we do know from the ratio that they gave us. All right, so tan is opposite over adjacent. But remember that with tan, working in quadrant 3, how the opposite and adjacent sides, your x and y values are going to be negative. And we know that negative 12 over negative 5 is 12 over 5. Okay, so those are equivalent. We need to find our third side. It's going to be 13. And I know that because it's a Pythag triple, 5, 12, 13. But let's figure it out. Your hypotenuse squared is your side squared plus your second side squared. So that's going to be 144 plus 25 is 169. So remember that when we're working out the hypotenuse, it's not plus or minus because the hypotenuse is always a positive length. Okay, it's 13. I told you. Yeah, nice, easy. We're literally doing Pythagoras, guys. These questions are free marks. Find the value of 10 divided by cos theta minus 5 divided by cos theta. So I'm not going to do fraction in fraction vibes. I'm going to say 10 divided by, so cos theta, cos is adjacent over hypotenuse. So it's going to be 10 divided by negative 5 over 13 minus 5 divided by, we just figured that out. It's cos again, hey. So there's negative 5 over 13. So the reason why I'm doing this is because it's not necessary, right? It's just so that we can nicely see when we do your tip and times, right? When we create that reciprocal fraction to simplify. All right, so now what happens from here? The 5 goes into 10 twice. So that's going to be 2 times negative 13 is negative 26. The 5 cancels out with that 5, and then we have the 2 negatives, so that will become plus, what will we left with? 13. So my answer will just be negative 13. Sweet. Let's go to question 3. Right, if 7 tan theta equals 3 and cos of theta is positive, find the value of sine theta plus cos theta divided by 2 sine theta. Okay, so I'm just going to mark off straight away where cos is positive because I don't have to do any manipulation or work there. But I do need to simplify. The 7 tan theta equals 3 will just become tan of theta equals 3/7, right? Divide both sides by 7. So that ratio is positive. Tan is positive. Boom, boom. Awesome. We're actually just working in quadrant 1. Amazing. So right angle triangle. Here we come. Theta, tan is opposite over adjacent. All right. So now I need to find my third side. This is not a Pythag triple. So let's see what it is. The hypotenuse squared is equal to side squared plus side squared. So the hypotenuse squared is 49 plus 9 is 58. Therefore, the hypotenuse will be equal to root 58. Again, the temptation is to change that root 58 into a decimal, right? Keep it as a surd, please. It just helps when you get to the simplifying bit. When you change it to a decimal and you round off to 2 decimal places, you're losing so much information about the number. All right, so leave it as a surd. We can actually answer the question now, hey? So sine theta plus cos theta. All right, so sine opposite over hypotenuse. So it's going to be in the numerator 3 over root 58 plus cos of theta is 7 over root 58. So plus 7 divided by root 58. Okay, we'll keep it as a big fraction for now. Actually, no. No, yes. No. Yes. So that's going to be divided by 2 sine theta. So sine we already said was 3 over root 58. Okay. So it's looking a bit like eek at the moment. But what are we going to do? Right, we're just going to simplify in the numerator. So 3 over root 58 plus 7 over root 58. If we add those fractions together, it's going to be 10 over root 58. That we are dividing by, so 2 times 3 is 6. So that we are going to divide by 6 over root 58. All right, you're saying 2 over 1 times by 3 over root 58. Okay, so that just simplifies to 6 over root 58. Now, let's tip and times. So 10 over root 58 times by So don't we feel so good now, because now that nasty surd just falls away. We don't have to worry about it anymore. He just cancels out. Blah, blah, off he goes. So we're left with 10 over 6. And let's not forget to fully simplify our answers. So 5 over 3 is your solution for question 3. Amazing. Right, so if 5 cos x plus 3 equals 0, and x is an angle between 180 and 360 degrees, find that. Okay. All right, so first part we need to sort out. 5 cos x will equal negative 3. So cos of x will be negative 3/5. So your ratio is negative. So where is cos negative? Done. 180 to 360. Well, that's in quadrant 3. 180 to 270, and quadrant 4, 270 to 360. My information overlaps in quadrant 2, in quadrant 3. I don't have enough information in quadrant 2, I've just got that one tick. So we're working in quadrant 3, where we've got 2 ticks, where my information overlaps. Alright, so that's my right angle triangle. X is the angle that they've given me to work with. Cos is adjacent over hypotenuse. So negative 3 over 5. Your third side using Pythagoras will be negative 4. Okay, we've dealt with this triangle quite a bit. And I keep talking about Pythag triples. 3, 4, 5 is one of them. So let's answer the question. 3 tan x plus 25 sine squared x. So 3 tan is opposite over adjacent. So 3 times tan of x plus 25 times. So sine is opposite over hypotenuse, and that is all squared. All right, so let's simplify. So the 3's cancel each other out here from the first part of the first term that we're working with. Those 3's will cancel out, and the negatives will then make everything become positive. So we're just left with 4. From the second term, so this is going to be 25 times by 16 over 25, right? Negative 4 over 5 squared. So the 25's cross cancel. So our final answer to get there, we're going to say it's 4 plus 16. So my final answer is 20. So this is the first question that we've seen of this kind, right? They've given us two different scenarios, basically. They're talking about an angle x. So cos of x is equal to 3 or 4. And then they refer to an angle y. How tan of y is 5 over 7. The angle for x is acute. It's less than 90. As well as for y. Prove that, all of this story. Okay, so essentially, what do we notice? That the ratios are positive, and it's between 0 and 90. So we're working in quadrant 1. What you're going to do is, you're just going to draw a little Cartesian plane for each scenario. So what I mean is, for, let's just get some colors. So for cos x is equal to 3 over 4, right? And we know that we're working in quadrant 1 because it says that x is less than 90. So I know that my triangle is just in quadrant 1. So I don't have to go filling in the CAST and everything else. I know we're working in quadrant 1. The angle that they gave me, angle x, cos is adjacent over hypotenuse. Now my third side, now I know I've been talking about Pythag triples 3, 4, 5. Remember that the hypotenuse is always the longest length. So that length is definitely not 5, all right? It's your Pythag triple is 3, 4, 5 on the condition that the longest length would be 5, right? The hypotenuse. So we're actually going to need to use Pythagoras here to determine what that length parallel to the y-axis would be. So the hypotenuse squared is equal to side squared plus side squared. So it's going to be 16 minus 9 is equal to y squared. And that will be 7. So your length for y would be plus or minus root 7. But where we are on the Cartesian plane it would be positive root 7, since we're in quadrant 1. Okay, so now let's consider when tan y is equal to 5 over 7. So now we're again just going to draw a little baby Cartesian plane. We know we're working in quadrant 1 because the function is positive and between 0 and 90. So I just draw my little right angle triangle. Here they said we're working with angle y. Tan is opposite over adjacent. All right, and let's find the third side. So your hypotenuse squared is side squared plus side squared. So that's going to be 49 plus 25, 69, 74. So therefore your hypotenuse will be root 74. All right, and let's just leave it in surd form. Okay, so now we can get to that bit over there. Let's figure out if that does equal 34. So let me just scooch my page. Scooch. Okay, so 74 times, so sine of y squared. So now what you do is you go into the triangle with the y, and sine would be opposite over hypotenuse, and we're going to square that. So it's going to be 5 over root 74 squared. All right, plus, so we're dividing here. So I'm going to do 7 divided by. So now they say tan of x all squared. So you need to go into this triangle now. So tan is opposite over adjacent, and we will square that. So that will be divided by root 7 over 3 all squared. All right, and now we just have to go about simplifying. So this will be 74 times by 25 over 74. All right, we square 5, we square root 74, and we can see what's nicely going to happen there. Those 74s are going to cancel out. Plus 7, so I'm going to do my tip and times already. So it's going to be 3 squared, 9, and root 7 squared would just be 7. So do you see how these questions actually really simplify down quite nicely in the end? So the 74s cancel out, and the 7s cancel out. So you're left with 25 plus 9 after all of that, which is 34. And the question said, prove that this is equal to 34. So therefore, the left-hand side is equal to the right-hand side. Okay, you've gone about and proven what they've asked you to do. Amazing. That wasn't so bad. Okay, last one. Let's jump right into this last one. If sine of theta equals k, whoopsie, what are we going to do? And if theta is between 90 and 180, okay, well, they've basically told me I'm in quadrant 2, right? They're saying that the angle is between 90 and 180. We're in quadrant 2, guys. So let's just draw our triangle in the interim with theta. Now, I know that some of you may be going, but what am I going to do with this? Because this entire exercise, I've been saying sine theta, cos theta, tan theta equals a fraction, equals a ratio. Now suddenly it's a letter k. You'll see that the question says find tan in terms of k. So it's fine that that letter is there. I could rewrite k. So remember that in all our previous questions, we were dealing with fractions, right? Because your trig functions create these ratios. There's a numerator and a denominator, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So we want a fraction. So how can I rewrite k so that it looks like a fraction? Well, if I say k divided by 1, we know that anything over 1 just is itself, right? So if I said 2 and I wrote 2 as 2 over 1, that's still, its value is still 2, right? So k over 1, the value is still k. But by doing this, we now know, okay, so my opposite length is k, and my hypotenuse length is 1. So you need to find your third side using Pythagoras. So the hypotenuse squared is equal to your side squared plus your side squared. All right, so I'm using x because I'm working along the x-axis, right? So what do we have? We've got 1 minus k squared is equal to x squared. Now we're going to square root both sides. Therefore, x is equal to plus or minus root 1 minus k squared. All right, and now I know some of you may be saying, I'm not allowed a negative under the square root sign, all of that story. No, we're cool. Remember that these are also two separate terms, so don't stress about that. All right, this is your third side using the lengths that we've been given. Your hypotenuse squared equals side squared plus side squared. And when we simplify, don't forget it must be plus or minus now because we're working with one of our side lengths, not the hypotenuse. Where I am on the Cartesian plane, the length will be negative 1 minus k squared. All right, so now I've got my third side, the value of tan theta. So tan is opposite over adjacent. So that's negative 1 minus k squared. And yeah, that's actually your final answer. And you've solved for tan theta in terms of k. So well done. Well done. If you got that right, you are amazing. If you didn't get it right, don't be bummed out. This was the first question of its kind that we've dealt with so far. So don't stress. Hopefully that makes sense. And congratulations, grade 11s, for working on the exercise, for committing to your maths. I'm super proud of you, and keep up the good work.